NeXHS Renewables, Mr. Sudhansu Bhusan Prusty. Request you all to please be joining us in this technology presentation also, and post that we have the last panel discussion of the day.
I'm Sudhansu Bhusan Prusty from NeXHS Renewables. To brief about NeXHS, we started in year of 2018, and with some young minds, with some disruptive ideas and innovative ideas to aid in construction. To aid investors in reducing the cost of energy, to mitigate the risk of the OEMs by providing robust technologies, and then to make the IPP happy by having trouble-free maintenance through digital technology and twin technologies. So I will be deep diving with 4 key points today on the innovation and technology that NeXHS does for, in terms of foundation evolution, in terms of tower evolution that we have been doing so far from last 6.5 years. And then on the operation and maintenance, we'll be talking on the digital technology in doing the operation and maintenance and digital twin. And then we'll be I'll be talking on the operation and, the logistics and supply chain challenges, how to mitigate through advanced technology. So these are some of the key areas NeXHS focus on. Like we do a foundation design for wall-type foundation, high-rise foundation, anchor-type foundation. Then we work on different type of tower technology. You might have heard of only traditional steel towers, but we have come across a different type of towers now, like lattice hybrid, concrete hybrid, then other forms of full concrete towers, which can reduce the capex. We also do feasibility studies like wind resource assessment, foundation assessment, soil assessment. We do project management consulting, like giving technical field assistance and then supporting technically to the IPPs and OEMs. And we do balance of plants. And in the onshore services, we do our area of services deals in foundation solutions, tower solution. And then we also now move on to offshore, transiting into offshore technologies on monopile foundations and then and so on. So these are our global networks. We support mostly all the OEMs and IPPs in India. And we are also present in the Southeast market, supporting them in providing engineering solutions. So, this is how the evolution we have brought in the foundation. Traditionally, we know that there is a standard foundation beneath the tower, which is never visible. But that supports the entire load of the turbine. And that's the critical structures, even though it is not visible. So now we started understanding the design philosophy better and better as the technology know-how has evolved. And now we are coming up with different type of tower technology, foundation technology like 8-wall, 4-wall, rock anchor foundations, 6-wall foundation, high-rise foundation, and turtle foundation. We took the concept of the the turtle, and then we designed a foundation turtle house. We made the cell very hard. As a turtle, the inside is very soft and the top portion is very hard, so that it takes care of all the loads that is coming from the turbines. So the way the foundation has been evolved from standard to a rock anchor and hybrid foundation is basically with the knowledge of how the load disperses to the ground. Like we want to channelize the energy in the right directions from the turbine top to the soil beneath. So that's how we have evolved with different typology of foundation. So there is a cost comparison when we are doing for a standard type, wall type, and rock anchor type. We found there is a cost reduction in 5% from a wall type, from a standard to a wall type, and again there is a 15% cost reduction in the in the rock anchor foundation. So like if you see from a standard foundation where the volumes were like 500 cubic meter to 600 cubic meter, we have reduced the volume of the concrete by, let's say, 180 cubic meter to 200 cubic meter for a 3 megawatt platforms. There is a drastic reduction of concrete. We talk about green, but the concrete is never green material. So we try to reduce more and more concrete to make it more greener. So again, on the towers, we have evolved with different kind of typology of towers. Traditionally, it was steel tower. Then we moved on to lattice tower. Then to concrete, full concrete towers. And then when the business case didn't fit in, then we moved on to lattice with steel tubular. And then moved on to concrete hybrid tower, which meaning that portion of the tower is concrete, like 80 meter. If there is a 140 meter height, we made approximately 80 meter as concrete, and the balance two sections, 40 meter as steel sections. And then now we come up with a space frame towers. Basically, this is a craneless technology that we have brought in, where it is like a traditional water tank structures, where the tower is just like the 6 pylons, and the turbine is fit on the top of it, which can reduce the cost drastically. So like, again, the cost comparison for a 140 meter or 3x platform tower, 3x platform turbine. When we did a cost analysis, we brought down from 610 lakhs to 501 lakhs by making it precast concrete, and then by making it hybrid, we brought the tower cost by 464 lakhs. So again, as we know, there are, when we go bigger in size in terms of tower, in terms of machines, then the real challenges comes in the supply chain and the logistics. So what we did is that we started looking at low bed trailers to transport sections which are much higher in weight, because trailer has its own limit to transport towers. And then we started having low bed trailer, you can see in the right side. And then we devised a saddle such that it can take a half the tower, transport half the tower, so that if you have, there are logistics restrictions for a diameter. So if you want to increase the diameter for bigger machines, then we have to reduce, what we have to do is that we have to come up with a split tower technology, and we have already ready with those kind of technologies. And then coming up with bigger machines, bigger challenges is the crane. And then we have also devised certain things like how to make things easier in terms of installation as well. So we changed our design philosophy from modularity to adaptability. Now people say that we will go with bigger rotor diameter and all, bigger machines. But why not bigger design life? That's how we want to change the concept from a bigger machine to in fact, the machine that is currently running, and increase design life by, instead of 25 years to 50 years. So we use the same capex, and then, or maybe a slightly increased capex, and then we can run this same platform without changing any logistics or supply chain, and move on with a adaptability kind of design. Basically, when I say adaptability, if I make a tower today, it can adapt to another future machines. It takes 25, it can eat away your design life by 25 years, let's say, for the current machines. And then we have balanced 25 years design life of the tower, which can take the next machine. So basically, we are coming up with a concept called load regulated foundation and load regulated tower. Meaning is that the foundation that is designed can take certain loads, but if you regulate it through pre-stressing and pre-stressing, we can increase the load carrying capacity of the foundation. Same way, if you increase the pre-stressing of the towers, we can increase the load carrying capacity of the towers. So in future, if you are coming up with bigger machine, we will be able to match up to that loads. And then coming up with a tower, if there is a frequency issues, we need not even change the mass of the tower. Rather, we can use technology in terms of dampers, or like sand dampers, oil dampers, or mechanical dampers to reduce, to work according to the frequency, that tune into the frequency that we wish to. Then coming to the offshore, that we are very nascent, India is very nascent to monopile, but we have been deep diving into monopile, hybridization of monopile, how to reduce the cost of the structure by improving the soil around it. Rather than increasing the structure, we want to improve the soil so that we can, with a reduction in the material itself, we will be able to manage with the reduction in the material cost. Then we are thinking of, we never thought of to change the input loads, change the loads that is coming from the wind. Now we started thinking to how we can reduce the load that is coming from the wind, like making a space frame towers and other things where the wind is through, so the loads are not directly coming, are passing through the tower, and the loads are not more on the tower. So that is the concept that we are bringing in to reduce input loads. This can be used in the offshore industry where the loads are quite higher. And then now, like this, between the foundation and the tower, there is an interface element that is called anchor cage. Earlier, we were using some 190, traditionally we are using close to 200 bolts. Then we are thinking now, why not use a step up, and that too of 4 meter, or now if machine size goes and increasing, we will slowly think of higher length of the bolts. But however, this will increase the cost of the interface element. So we have come up a concept called stepped anchor cage to reduce the cost of interface, meaning that half of the portion will have a reduced number of anchor bolts and the top half will have a different kind of anchor bolts. So which can reduce the cost drastically in terms of interface element is concerned. So these are some of the challenge philosophy that we have changed in the wind industry in terms of structural thing is concerned, so that to reduce the capex of the machine. So evolution of O&M through digital tech and digital twin. Earlier, traditionally, it is more of mechanical oriented, that is done at site for O&M. Like if there is a blade repair, people climb in ropes and do the repair of these blades. Or if it is a tower defects, same is applicable. But now we have our own drone technology where drones fly into the turbine, and then we get the information through satellite sitting in the desktop, and then we get the exact. We do a twin model in our desktop, and it creates a twin model. I mean exactly the replica of what exactly where the crack is, and then we just analyze do the analysis of the structure and give a retrofitting solution to the structures. So it is seamless. Like drone gives the pictures, and then the pictures are giving a twin exactly the replica of the turbine and the defects, and then the defects are analyzed, and then we get a drawing out of it, and then we send it to the site and then do the retrofitting measure for this. So I'll quickly run down through a video. This is like a 4-wall foundation. This typically how a foundation look like. Earlier, you might have seen of traditional foundation like slab type, but this is something a different kind of where we channelize the energy in the right direction, 4 direction to the soil. This is what we were talking of a turtle foundation look like. We were reducing the excavation quantity, like now the excavations is a challenge in different areas where like blasting is not permitted. So with a lesser excavation cost, we can save the foundation in such a way that we reduce or minimize the cost of the excavation. This is something called a rock anchor foundation. We have drastically reduced the concrete by almost 60 to 70% of the current volume that we are doing for a traditional foundation. So it is only the anchors embedded into the rock. You can see here, it's a instead of a traditionally 22-meter foundation, we have reduced the diameter to 12 meter only. And the volume of concrete, which was 500 to 600 cubic meters, is now brought down to 180 to 200 cubic meter. So this is another technology on tower that we are developing. That's a space frame tower. You can see like how easily we are making without a crane. We are taking a robot inside. You can remote control and do the tower erection. You can do it through a remote control itself. So it is no more a laborious job. So you can see the complete towers. And this is a hybrid tower. Part is concrete and part is steel. So you do the pre-stressing from outside. And then coming to O&M, operation and maintenance, we use digital technology in terms of drones, which you can see that the damage can be detected and can be analyzed sitting in the desktop. So this drone moves on and put a robot, and then it does seamlessly without any manned labors. Okay, we have to collaborate together, OEM, IPPs, and NeXHS as such, to bring down the cost of energy. And that's all from my end. Thank you. I was told to make it in 10 minutes. I think hopefully I have made it lesser than 10 minutes. Oh, is it? Okay, thank you.
Thank you, Mr. Prusty. Just if you can be with us for another minute, would like to request Mr. Mahesh Vipradas, the Vice President of WIPA, to please join us in presenting the memento, and thanking you for sharing with us your performance efficient and cost efficient WTG structures.